Hi, folks. Today we're going to start talking about Chapter 5, which gets into the concept of elasticity. Now, when we talk about elasticity, what are we actually saying? What is this word? Well, if you noticed, every graph we've kind of drawn to this point has been a perfect 45-degree angle, right? So just a straight horizontal line. Um, in reality, not every demand curve, not every supply curve, not every change in quantity demanded, not every shift looks perfectly nice and even in 45 degrees. There's no reason it should. And so to understand how variables actually change in a relationship to one another, we have elasticity. And elasticity is a measure of the responsiveness. Let me get my pointer up here. Elasticity is a measure of the responsiveness of quantity demanded or quantity supplied to a change in one of its determinants. Now, there's a lot of different kinds of elasticity, but first we're going to look at the elasticity of demand. Now, the price elasticity of demand is a measure of how much the quantity demanded of a good responds to a change in the price of that good, computed as the percentage change in quantity demanded divided by the percentage in price. To put it in simpler terms, we say that the point elasticity of demand equals the percent change in the quantity demanded versus the percent change in price. This is called the point method of elasticity. Now, what do we mean when we say these things? Really, what we're kind of getting at is we know from chapter 4, right, that the law of demand states that an increase in price changes the quantity demanded. But how much does it cause that to change? So, for example, if I am selling coffee and I increase the price of my coffee from $2 to $3, how much does demand for my coffee go down because of that change? That's a 50% increase in price, right? So the curious question is, does a 50% increase in the price of this coffee cause quantity demanded, i.e. the amount of coffee people are buying, to go down 50%? Or is it people say, well, $1 extra, excuse me, $1 extra, that's not a ton. Maybe I am willing to pay that. And maybe quantity demanded for coffee only goes down 10%, 15%. This has a lot of implications. Now, for the point method of elasticity, I don't have it called up here. Unfortunately, the textbook doesn't provide an example, but I do want to specify this out loud very clearly. To calculate the point method of elasticity, what you would do is you take the initial quantity, you subtract the new quantity demanded you're moving to, and you divide it by the original quantity. All right? And then you put that above your original price minus your new price over the original price, and you'll get two fractions. The top fraction is the percentage change in the quantity demanded, i.e. the difference between your old quantity demanded and your new quantity demanded over the original quantity. And you'll get the percentage change in price beneath that, i.e. the difference between your old price and your new price over the original price. But typically, we don't use the point method. Instead, the method we use is what we call the midpoint method. And we'll get to that in a second. Other determinants for demand elasticity. So we talked, right? So our first one was price elasticity. In reality, price isn't the only thing that affects quantity demanded. For example, we talked about shifters in chapter 4, right? Shifters move quantity demanded. It doesn't move it the same way, but it does move it. So our shifters, in fact, impact ultimately our quantity demanded. For example, the availability of close substitutes. Insulin for diabetics has no particularly specific alternative, and so insulin has a very inelastic demand, and what that means is that it won't change as much. The demand for it won't change as much in response to price. Similarly, Advil, however, has plenty of other substitutes, right? You have Tylenol, you have Advil, you have generics of both, and you have other painkillers as well. So Advil is more elastic than insulin. Additionally, you have necessities versus luxuries. Food as a general category is less elastic than luxury cars. It makes sense, right, that the demand for Ferraris would change dramatically if Ferraris lowered their price. Similarly, food, you pretty much need to consume as much food as you need to consume. So unless you're priced out, it's a fairly inelastic demand. The definition of the market, this largely depends on how many buyers, sellers, competitors, alternatives, um, the need of the product. That's an aspect of the definition of market. These can all determine elasticity. And the time horizon. Long-term more elastic than short-term. This simply means that over time we expect a lot more changes in the market, and that can affect quantity demanded. So just think of, for example, currently your favorite restaurant where you live. It may be your favorite restaurant today, and you may demand it at a high amount, but over the long term, your taste and preferences are going to change. New restaurants can enter into the market. The place you really like can get too expensive. All these things factor into the fact that while demand is pretty predictable today, over the long term, it's not quite sure how high on demand that product will be. Similarly, broadness of category. Coffee beans demand are more inelastic than Jittery Joe's coffee, i.e. a specific brand. Just to give you kind of a classic example here, you may be like, I am drinking coffee this morning. And Jittery Joe's may all of a sudden price their coffee to where a black cup of coffee is $6. You're still going to drink a cup of coffee, i.e. something that uses coffee beans. The only difference is you're not going to use Jittery Joe's. You'll swap to a different brand. And so that's sort of the aspect of the broadness of category. The bigger the product, so for example, wheat, it doesn't matter what bread you buy. The bread may be more susceptible to price changes. It doesn't matter what bread you buy, but wheat will be consumed no matter what loaf you buy. So that's the logic there. Now, what formula do we actually use to calculate most of our elasticities? This is called the midpoint method. And what the midpoint method is it is the percent change in quantity over the percent change in price, but it's a different kind of, it's different in one aspect. It's now the percent change over the average of your 2 points. And the average of your price points. So this is why it's called the midpoint formula, is you still calculate the difference. So you have new quantity minus the original quantity over the new quantity plus the original quantity divided by 2. So up top you have the difference, and then down here you have the average, or i.e. the midpoint between your 2 points. Similarly, on the bottom you do the exact same setup. You have the new price minus the old price over the new price plus the original price divided by 2, again calculating the average down here. Now, the beautiful aspect of this is that this is the exact same elasticity equation you will use in all settings. It doesn't matter what you are calculating, it will be quantity on top compared to the price of another good. I want to be clear about this. There's different types of elasticity, but the math will be this exact same formula here. The only difference is you may have the quantity of a good versus the price of an entirely separate good, and we will get to that example in a second. But for our purposes, just take a moment to calculate out this example here. So you have an original price of $2 where 100 is the quantity demanded, and you have a shift from $2 to $3 with 80 quantity demanded. So what you would do is we'd come over here and we plug in 80 as our new quantity minus 100 over 80 plus 100 divided by 2. And then you would also come over here and put 3 minus 2 over 3 plus 2 divided by 2. You'll get two fractions, simplify that down and solve, and that will tell you the elasticity for this specific good. Now, one more thing you need to add that is not included in the lines here, you have to absolute value the final number. So what that means is you will put double brackets around the final number, and that will make it just a positive number. So it doesn't matter if it's negative or positive for the price relationship right now. It will for other elasticity. So why are we interested in elasticity? Well, the reason is that there's a variety of different kinds of demand curves. You have an inelastic, unit elastic, and an elastic demand curve. So an inelastic demand curve is a more vertical steep slope. And what that says is that the variable is relatively insensitive to price changes. And when you mathematically calculate this, this will mean the elasticity is less than 1. And you'll see that in the graph, the elasticity is also the slope of the graph. But what we mean by the variable is relatively insensitive to price changes, I want you to go back to, I mentioned insulin as a fairly inelastic good. What that means is that for people that are diabetic, you have to have insulin. You can't really regulate or control how much insulin you need. You can to some degree, but if the price of insulin goes up, the diabetics will have to pay that amount of money. In a way that means that it's relatively inelastic. So if insulin's price went up 10% tomorrow, the amount of diabetics in the world hasn't really changed, and they will still continue to need that amount of insulin. If you're wondering, part of the reason why medical costs are so expensive is because pharmaceutical companies have a tendency, particularly if they have a rare drug that is absolutely needed, they can raise the prices on it and they know that it will be paid for. Medicare can negotiate healthcare prices. So Medicare, for example, pharmaceutical companies will know there's a steady demand, that the demand's relatively inflexible to price changes, and so they will upcharge prices. Unit elastic, sorry, not United Elastic. Unit elastic, this is going to be the perfect 45-degree angle, and the elasticity comes out exactly to 1. And what this means is an exact change in price equals an exact change in variable. So, for example, if price increases by 5%, it means your quantity demanded goes down by 5%. That's why it's the 45-degree angle. An elastic slope, this is more horizontal, flatter slope. It shows the variable is relatively sensitive to price changes, and it means you have an elasticity of greater than 1. So for example, the easiest I can think of is, think of like Sam's Choice Cola, right? Sam's Choice sells because it's the cheapest cola, or one of the cheaper colas. Imagine if Sam's Choice changed its price to the exact same price as Coca-Cola. Demand would drop noticeably, significantly. And the question is, would it drop as much? Yeah, it could very well drop more in quantity demanded than it does in it increases in price. And so that's elastic. Is this will mean a situation in which the percentage change in price leads to an even larger percentage change in quantity. So what do these elasticity curves look like? Well, here's an example. Here's an inelastic supply curve. So an inelastic supply curve is very steep. So you have an example here. You have a price of 80 combined to 60, and the price moves up to 26. So that's over, if you think about it, right, that's over a 25% increase in price. The quantity only moves up to 64 for supply. So that's a relatively inelastic supply. So that means that you charge and price increase significantly, and the coin supply is not going to go up. And if you calculate this out, what you'll find is you have 4 over 60 over 26 over 80, and you get equals about 0.2. So that's less than 1. So you have about a 0.2 slope on this inelastic supply. Perfectly inelastic supply, this is a special case in which the elasticity comes out to exactly 0. So notice that we moved the price from 80 to 106, and the quantity stays the exact same. So if you did the math, you'd solve and you'd find that this equals 0. And that is a special case of perfectly inelastic. This means that supply is completely immune to any change in price. Now, here's other examples. Demand, perfectly inelastic demand looks the exact same. Quantity demanded is not changing at all with respect to price. Perfectly elastic, this actually means you have a slope of infinity. There's not anything that actually really does this, but the important point here is for perfectly elastic, you have a slope that is constant and flat, and that means you can sell as much as you want as long as you're at that price. This bottom left-hand corner graph, this is unit elastic. Notice it's that 45-degree angle downward. And this means that for every percentage change in quantity, right, we're also getting this exact same percentage change in price. So if quantity is down 5%, price must have increased by 5%. And this final far right panel, this is also a unit elastic curve. The only difference is it has a bend in it. And the purpose of this curve is to show you that there are changes, that curves are not necessarily static in the sense the slope is always the same, and that the slope can fluctuate over time. And so we're relatively inelastic in demand at these high prices, but as we get cheaper, we get much, much, much more elastic. So total revenue and elasticity. Why do we care about elasticity? Is that it actually does have this connection to total revenue. So think about inelastic. Inelastic, right, is telling us that if we change the price by 10%, we can expect our quantity demanded to change by less than 10%. What that means is that we actually maximize revenue when we increase prices. So for example, total revenue equals price times quantity. So price increases, say 10%, and quantity demanded goes down only 2%. We've increased our total revenue. And so an example is pharmaceutical prices. Unit elastic, this tells us there's no change in revenue based upon price change. Cola increased their prices due to trade restrictions. Recently, sales are still fine. They're relatively equivalent. Similarly, for elastic, what this tells us is that revenue actually is increased when you decrease. To be clear, when you decrease your price. So for example, we're talking about a situation, and if I lower my price by 2%, my quantity demanded goes up by 5, maybe 10%. So that means that the gains I get from selling more offset the reduction in price. That's an example of elastic. And the relationship between elasticity and an elastic good and total revenue. Other elasticity, well, remember how we said in chapter 4 that demand can shift based upon the price of other goods? Well, that's true for elasticity too. Cross-price elasticity is a measure of how much the quantity demanded of one good responds to a change in the price of another good, computed as the percentage change in quantity demanded of the first good divided by the percentage change in the price of the second good. Basically, it's the exact same elasticity question, just instead of the price of a good we are curious about, we replace it with a substitute or a complementary good. So for example, let's say that we're interested in the quantity demanded for Coca-Cola, elasticity of Coca-Cola. The midpoint formula and the demand elasticity of Coca-Cola was simply how much does the demand for Coke change if we change the price of Coca-Cola. The cross-price elasticity is if we put, instead of the price of Coca-Cola, the price of Pepsi as our other good. The math is still the same. We're still interested in the quantity demanded of Coca-Cola. The only difference is we're now looking at how much it changes based upon the change in the price of Pepsi. So, if the relationship is positive, elasticity is a positive number, this means substitutes. So for this point, at this, like for cross-price elasticity, you don't want to absolute value this final number. Now we're interested in the signs. So for example, if Pepsi cuts their prices, we would expect the quantity demanded of Coca-Cola to also go down, right? So if they both go down together, that's two negatives, cancel out, you get a positive final elasticity. And that's how you know it's a substitute, is that the price of the substitute going down means the quantity demanded for the main good goes down as well. If the relationship is negative, i.e. elasticity is a negative number, that means they're complements. So for example, say Coca-Cola and pizza prices go up dramatically. If you see that pizza prices go up and the quantity demanded for Coca-Cola goes down, so you have Coca-Cola's quantity demanded being a negative number and the price of pizza going up being a positive number, that's an example of a complement and how the elasticity and quantity of Coca-Cola is affected by the change in a complement, say pizza. Better example might be movie popcorn. So let's think about the quantity demanded of Coca-Cola at movie theaters and the price of popcorn at movie theaters, right? Because you don't really do one or the other, you do both. If the price of popcorn goes up, right, the quantity demanded for Coca-Cola at movie theaters goes down. So complements. Elasticity of supply. This is exactly the same as the price elasticity of demand. It's a measure of how much the quantity supplied of a good responds to a change in the price of that good. Compute as the percentage change in quantity supplied divided by the percentage change in price. Computing elasticity of supply, literally the exact same as demand. Just swap quantity supplied and quantity demanded. Same math, promise. So what you would do is the price elasticity of supply equals the percent change in quantity supply over the percent change in price. You'd use the midpoint formula for this example as well. So nothing particularly flashy here, just to go back, skip back here just to say. So when we were looking at the midpoint formula, all you would do here is this would be the elasticity of your supply, and you would have the percent change in the quantity of the goods supplied over the percent change in price. Note this relationship should be positive, right? You should expect the quantity supplied to go up as the price goes up, as we talked about with the law of supply last chapter. Now, finally, I just want you to sit here and think about what the answers are for this section. You have the options of perfectly inelastic, inelastic, unit elastic, and perfectly elastic. Just kind of pause for a moment, consider these curves, and decide how the elasticity is of them. You can kind of calculate out with some of these numbers, but again, just kind of think about or consider which one is elastic, which one is inelastic, just for practice, and think and reflect and pause. Honestly, folks, this is it for this video. It's a short section, but it's an important section. It explains a lot of economic interactions. We'll talk about welfare later and how welfare is affected. Elasticity has an important and crucial role in determining who benefits and who loses, and how significant are the gains and losses from certain policies. All right, folks, I'll let you think on this. Take care. Best of luck until next time. See y'all.